will have a varied degree Waterworks' ideal pH stand enhances the natural buffering capacity of any ideal EQ. The ideal pH stand is a discrete, compact, and flexible system engineered for operators and maintenance personnel to perform their duties safely and effectively. To control the pH, a side stream is drawn out of the EQ tank by the recirculation pump, flows through the pH stand, then back into the tank. As the water enters the pH stand, a controlled portion flows over a pH probe for continuous measuring of the pH level. The system is designed to allow the operator to safely and easily isolate the probe for cleaning and calibration. A dedicated controller will constantly monitor the pH level and control the chemical pumps. If the pH reading dips below the set range, a caustic chemical pump will turn off and raise the pH back to the optimal level. In the same way, if the pH reading raises above the set range, an acid chemical pump will turn on to lower the pH back down. World Water Works programs the chemical pump speeds to ramp up and down depending upon the deviation from the set to prevent the pumps from overshooting. Mixing acid action if not properly managed. Because of World Water Works has programmed several safeguards. A flow switch is installed on the pH stand to ensure the chemical pumps can only run if there is flow moving across the probe. The programming does not allow for the acid and caustic pumps to run at the same time. Chemical injection points are engineered into the stand to allow for dosing in a safe, controlled environment. These injection points are at a set angle to further reduce the risk of a violent reaction. An equalization system is a vital piece to the operation of any wastewater treatment plant.
So look at what makes the A200 tick. Check valves. Diaphragms. The diaphragm rod assembly, the main air valve, and the pilot air valve. Now that you know the key components of the A200, we can discuss how it works. Two diaphragms connected to the pump. While one side is in suction mode, the other is in discharge mode. As a diaphragm moves inward, it creates suction. This suction motion causes the balls to move towards each other. As this happens, the top valve closes and the bottom valve opens. This allows liquid to enter the chamber through the bottom port. As the diaphragm moves, as this happens, the top valve opens and the bottom valve closes. This allows liquid to exit the chambers and discharge through the top port. This process constantly alternates between the two chambers to create a continuous. So look at what the other is in discharge. Diaphragm moves inward. It creates suction. This suction motion causes the balls to move towards each other. As this happens, the top valve closes and the bottom valve opens. This allows liquid to enter the chamber through the bottom port. As the diaphragm moves outward, the discharge motion causes the balls to move away from each other. As this happens, the top valve opens and the bottom valve closes. This allows liquid to exit the chambers and discharge through the top port. This process constantly alternates between the two chambers to create a continuous cycle. The pump diaphragms are driven by pressurized air that is directed left and right by the movement of the main air valve. Here's how it works. When air pressure is applied to the pump, the main air valve moves up and down. When the main air valve is in the down position, air pressure is diverted to the right diaphragm. At the same time, exhaust air from the left diaphragm passes through the shuttle and shuttle plate and exits the rear of the pump. When the main air valve is in the up position, air pressure is diverted to the left diaphragm, while the right diaphragm is exhausted. This process constantly alternates between the up and down position to create a continuous leave. Chamber 3 is always under pressure. When the pilot air valve travels far enough to the right, chambers 3 and 4 are connected. This allows the pressurized air from travels far enough to the left. Chamber 3 connects to chamber 2, and the air moves the main air valve downward. This causes the right diaphragm to pressurize and the pilot valve to begin moving right. Throughout the cycle, one side pressurizes as the other exhausts. This process constantly alternates between the pilot and main air valve to create a continuous cycle. Simple, straightforward design of the All-Flow A200 allows the air and liquid ends to work together reliably to transfer your process fluid in the most efficient manner possible.